I think it's already being recorded. All right, so let me just explain to you the rubric that I'm using in scoring your hands-on activities as well as the other skills exam, no? So that you will have to aim for better scores, no? So most of you only get the 3+3 score, which is the satisfactory point. Although you perform the activity, most of you will notice that this is the only score that you get, no? So most of you may ask, why do I not getting a score of very satisfactory? Okay, the score of very satisfactory tells us that you have to apply the most appropriate modern technique in performing the discipline-specific engineering task, no? And this is your activity. And you need to exceed the requirements. So that means when you submit something, make sure that you exceed the requirements. No? If you only answer the activities and as well as the supplementary activities, if there are, okay, so that means you only getting a satisfactory score. Okay. However, if you did something more than what is required, so you will be getting a very satisfactory score. And in case that you did not do the other things, for sometimes incomplete kayo, but you did some part, so you will get a developing score. Okay? Yung 2+2. And for those who get 3, 5, so those are in between the satisfactory and developing, and then the unsatisfactory. Most of you will get, some of you will get unsatisfactory score, no? 1+1. That means ang magiging score nyo lang is only 2 points. No? So what does that mean? That means that you submitted a report or an activity that do not satisfy, no? Do not satisfy. You failed to identify, and then of course in your solution you did not able to submit a correct solution. So yun yung magiging scores natin. So I hope that is clear to everyone, so that we can actually aim, no, if you are aiming to be a scholar, no, so having a grade of 6 is having a grade of 8 is better than having a grade of 6, no? Sayang din yung 2 points. Okay, so you have to aim for exceeding, doing something that is beyond the requirements. So yun yung laging ine-emphasize namin para makakuha tayo ng very satisfactory score. Okay? So much for that. If you have some questions, you can ask you can use the public chat, no? Or the chat box for question and answers, or you can use your microphone if you feel that you want to actually want to know something. Okay, anyway, if there are no more questions, I think we can proceed now with our lecture today, which is, let me just fix the this one. So where is the, medyo nangangapa pa ako dito. So I have the participants here. Where is the chat box? Okay, this is the chat box, so I'm going to put it here so that I will know if you have some message now while I'm discussing. Okay, so let me share to you the screen for the module 4 lecture. Okay, can you see it now? Everyone, can you see it? Okay, thank you. Thank you for the response. Okay, let me start the lecture today. The topic today is all about time series. And at the end of this learning module, you should be able to explain the concept of time series. No? What is time series? What does it do? how to manipulate time series, what are the different type of time series. So how are we going to train uh, using deep learning the time series that we have. Okay, and then of course you should be able to differentiate stationary from smoothing time series. No, we'll try to explain those and analyze and apply the concepts of Kalman filters and signal transformation in time series. And then of course finally you will be able to design and build a model using deep learning in time series. All right, so let's go with the time series. So basically, what is the definition of a time series? It's a sequence of data points now organized in time order. So that means data points are given an appropriate uh, time order. Like for example, it can be per second, it can be per minute, it can be per hour, per day, per month, per year, etc., and so on. And the sequence that we have captures the data at equally spaced points in time. Okay, and the data collected that are collected, for example, irregularly, cannot be considered as a time series. So that means we can only tell that is a time series if they are collected regularly. It can be either per second, per minute, and so on. Okay. Now, a time series is a sequence of information. It attaches a time period to each value. And then the value can be pretty much anything measurable that depends on time in some way. No? For example, prices, it can be humidity, temperature, or it can be a number of people. No? For example, people that are arriving in an airport, people that has COVID infection, yeah, something like that. No? As long as the values we record are unambiguous, any medium could be measured with time series. So this is an example, as you can see from the page. This is a monthly cases of chicken pox, no? And you can see here that um, the record that you see from here is um, in terms of the cases of chicken pox. These are monthly cases. So given in periods of month, no, from 0 to 500 months. So this is a lot of data, no, that were gathered. No, it's a representation of a time series. Now, time series data is common across many industries. No, for example, you can see time series in finances, such as stock prices. You can also see asset prices, macroeconomic factors. Also in e-commerce, you can see some page reviews or page views, how many number of users, how many searches. No, those are the things that we can see that are organized in a time series data. And as well as in businesses, no, we can see a lot of those time series in terms of transactions, revenue, inventory levels, and so on. There are plenty of examples on this, no, and you will be understanding that time series methods are used to do the following. Number one, no? Number one thing that a time series method can do is to understand the generative process underlying the observed data. And second, we can be able to fit a model in order to monitor or forecast a process. So using time series, we can forecast a certain process. So what are the different application of time series? So we can, as said, no, we can use it for economic forecasting. No, like for example, macroeconomic predictions such as WTO time series forecasting to predict levels of international trade, and then Federal Reserve, they use also time series forecasts of the economy to set interest rates. In stock market analysis, time series are used and they are associated with stock or share market, and they are focused on uh, and buying, selling something, no, for the investors. The common trend towards the stock market among the societies that it is highly risky for investment or not suitable for trade. So most of the people are not even interested in trading, no? So takot ang tao na pumasok sa trading because of the volatility of the market. Now, the seasonal variance and steady flow of any index will help both existing and naive investors to understand and make a decision whether they want to invest in the stock or share market. So to solve these problems, time series analysis is a tool that they use so that they can forecast the trend, no, or even the future. So the trend chart will provide adequate guidance for the investor. So basically, if you are a stock market investor, you use the stock market analysis para ma-guide yung mga investor for either do they want to buy the stock market or they want to sell their existing investment. Okay, another application of time series in terms of demand planning and forecasting, no? So basically, they are used to predict the demand, no? For example, the demand in the electricity, no? For example, in other countries they do it, no? In Taiwan, in United States, in Europe, in the Middle East, they perform demand analysis for how much power do they need, no? Not only did you know that not only in the 24-hour period or in a month period or in a year period, they do prediction in terms of 5 years from now, no? Kung ilan yun yung mga study na ginagawa ngayon ng mga electrical engineers, no? And I have been a recipient of that study when I was in Taiwan, no? Yung focus ng direction ng kanilang research is more on the forecast of how much demand in terms of electricity. Okay? So yun yung kanilang ginagawa, no? So they use the demand forecasting in order for them to plan, no? Kung ano yung mga susunod nilang plan. Kailangan ba nilang magtayo pa ng mga planta ng nuclear power plants, ng mga renewable resources, something like that, no? So importante para sa kanila itong time series analysis because they can actually do those things, no? So that it can help them to grow their economy better. Okay? Unlike here in our country, ang ating pinipredict lamang dito is we don't usually, I don't know if there are some studies, no, or research that focuses on energy, no. I don't know if in UP, no, because most of the researchers are in the University of the Philippines and other uh, uh, what do you call this? In other universities. I don't know if there are uh, prestigious universities or schools that are focusing on the forecasting of the demand, no? And as well as, of course, if you want to do those things, no, you need to analyze. You know, you need to better analyze the trend, no, in terms of the demand in electricity and etc. etc. And anyway, the market for electricity is very volatile as well, no? So once they are generated, no, there is once electricity or energy is generated, no, it's very hard for them to store the energy. So that is one problem that we can actually uh, um, think think upon, no? Okay, so meron tayong latecomer dito, si Giyab. Okay, so let me just tick on the late. So, dumating na ba si Salem and Toribio? Because they are only the people that are not here. So, Salem and Toribio are still not here. Another thing that we can apply time series forecasting is in terms of anomaly detection, no? So, particular kind of time series analysis. For example, also in Taiwan, I saw some students there, no? They are studying about the anomalies of signals in terms of an electronic component, no? I have seen some students from they are graduates of Adamson and other schools like Mapua. They're studying in Taiwan, and their focus is to detect some problems in terms of the signals that are generated by electronic and electrical um, devices, no? And they do it using time series analysis. So the best thing to do it first is to actually create a circuit that will collect the generation of signals, and then from there, after their collection, kapag ka meron na silang enough data, they can actually create a model on how they can actually detect, no, some problems. There was also a project in project design last year, I think, no. So the project is all about detecting the malfunctions of the parts in a automobile system. So through I don't know if they use the time series, but there was a project like that. I think it was already done, and it was defended, um, and it passed, no. So I think they were already graduates of CPE. So I think they use time series for that. Okay, so basically we can do those things, no, in application of time series, and there are a lot of things, no, that we can also uh, do in time series. Like for example, yung si Sir Joel Martinez, which is my buddy in Taiwan before, last year, before the pandemic came. Buti nakauwi kami agad, otherwise naipit kami sa Taiwan. Um, yung project niya is all about the radiance, no, coming from the sun. So mini-measure niya yung radiance coming from the sun for different locations. And ang ginawa niya, yung images that were gathered, no? Kasi yung data set that are available for the radiance are in a in a in an image, no? So naka-image yung data set na kinuha niya. And meron siyang ginawang method na, alam ba ninyo na ang images can be converted into time series. So kinonvert niya yung images na yon into time series, and then nung meron na siyang time series, so ina-analyze niya yon, and then nag-create siya ng model, and from there doon pumasok yung kanyang study. So yun naman yung kanyang study. Okay? So basically ang daming application ng time series. So pwede talaga natin siyang gamitin sa maraming mga bagay, no? And audio signals can also be generated as a time series, no? It depends on your study. Okay, now, but basically all of the time series has its own typical components, no? And in this part of the topic, we'll try to discover the components of time series. So the first component is the trend, no? So what is a trend, no? As you can see from the image here, there is a signal. Okay, this is a time series, no? The signal in the block, no? The line plot in the block, colored block lines. So this is what we call the time series, no? Drawn here is a regression line, no? And this regression line is acting as the trend, no? So what is a trend? It captures the direction of the time series. So as you can see, the regression line is on an uptrend, no? We call it uptrend because it's coming from the low part going towards the high part, no? So basically ang tawag doon ay uptrend. Kapag ka pababa naman, downtrend ang tawag doon. Okay? So yeah, no? Those are some example of what we call a trend, no? So you can basically think of an idea. For example, here you can see in this part there is a growing or increasing job growth year over the year despite seasonal fluctuations. Of course, in some parts of the months there are fluctuations, but you can see the trend seems to go uptrend, no? It's increasing, no? So you can basically see whether the trend is increasing, that's an uptrend, or decreasing, or what we call the downtrend, no? It can also be a constant, no, constant trend, meaning there is a steady direction, no, in the case of the trend, no. And it can either increase or decrease in different ways, no. It can increase linearly, or it can be exponentially, or in other ways. Okay. Another thing that you need to understand about the components of time series is that we can actually see the seasonality. So what is seasonality? It captures the effects that happen when with specific frequency. No, like in this case, you can see that the seasonality here per month in terms of the number of jobs. No, you can see here that um, in terms of seasonality, you can see that the trend of the signals, no, generated by this time series is going typically the same, no. It's going up and going down at a particular period of time, going up, going down at a particular period of time, no. So basically nakikita nyo parang kinaka-copy paste lang yung each phase, no, per period. Parang kinaka-copy paste lang yung trend, no. So it happens during the season, no. So ang tawag diyan ay seasonality. So this seasonality can be driven by many factors, and sometimes it can be referred to as natural occurring events, such as, for example, weather fluctuations, no, caused by time of the year, no. So during the summer makikita natin yung signal ganito, during the winter season or spring or fall, which is wala sa atin, meron lang tayong dalawang season, which is rainy and summer, no. Pero sa ibang mga countries, they have 4 seasons, no. And makikita niyo yung trend ng ng time series pagka ganoon ay you can see that parang parang kina-copy paste nga lang yung ano. Yun yung explanation ko dito sa seasonality, no. Parang kina-copy paste lang yung earlier ano, no. Yung so there is an uptrend and then it will go down and then up again, and depending on the time series, no. Like in this case, yung seasonality nito, you can see that the local job growth, no, during the first 10 months, for example, you can see that in the 5th month tumataas siya, pero pabagsak siya ng pabagsak going to the 8th month or 9th month, no. Tapos that pagdating natin ng 10th month, ganun na naman, no. So basically makikita nyo 5, 10, 15, pagbalik dito bababa naman siya sa 20th month, etc., etc. So makikita nyo yan, no. So seasonality also is caused by for example, holidays or religious observances, no. Like for example, when we are looking at electricity consumption, for example, no. So you will see that there's a lot of seasonality in terms of electricity consumption during the holiday. So iba yung trend ng need kapag ka-holiday kesa sa non-holiday, no. So makikita nyo yung trend na yon. So you will see some seasonality. So ang tawag doon ay mga fluctuations due to calendar events such as the number of Mondays per month, no. Yan. The number of holidays that are taking place. Okay? Now, yung residual naman, which is the third component ng time series, is what we call the random fluctuations, no. And pwede natin sabihin that these are the leftover after trend and seasonality are removed. Ibig sabihin sa isang signal, pag tinanggal natin tong trend, pag tinanggal natin yung seasonality, ang matitira dyan ay residual. Kaya nga ang tawag dyan ay residual, or what we call the remainder, no? Yung remainder ang tawag dyan. So you can see from the figure here, this is the observed signal, and then you can see the trend, no, it's going upwards. It's not linear, it's somehow curved in nature, and then you can see the seasonality, no. This is the seasonality of the signal. And then the residual is when we try to remove the trend and the seasonal. So ito yung matitira. Kaya siya ang tawag sa kanya ay residual. So how do we remove the portion of the trend or seasonality components, no? So, para ma-remove natin tong trend and seasonality, dumadaan tayo sa tinatawag na decomposition. And we will study about that later, no? Kung paano natin gagawin yung decomposition. So let's try first to demonstrate some components. Now, we will try to create a time series here, okay, in our demonstration. So first of all, we need to import the following libraries. So meron tayong matplotlib, gagamitin natin sa plotting. So of course, ito, import sys will be used for accessing the library for the system of the operating system. And then stat models will be used for basically doing some stat modeling. And then of course, NumPy, meron tayo yan. Matplotlib is used for visualization. Okay, so let's try to run this. Okay, and then let's try to run the different versions. No, so you will notice that when you try to run this, kung wala kayong naka-install na stat model, so you may need to install your stat model. No? So pip install stat model para malaman nyo kung ano yung version ng ano nyo. So in case na meron naman na kayong stats model, so there's no need to install. Right away, makikita nyo na kagad yung version ng inyong libraries. No? So piniprint natin dito yung library ng matplot, NumPy at saka stats model and the different versions. So right now I have this following values. Ang matplotlib ko is 3.2.2. It may differ from you. And then NumPy is 1.18.1. And then stat models ko ay 0.11.1. All right. So in the section 1, we'll try to create a fictional trend. No? Magko-construct tayo ng fictional trend, seasonality, and residual components. No? And this is just to show you an example of how a simple time series data set is constructed. But this one will later aid you or help you in understanding how to manipulate time series. No? In the meantime, let's create a time of interval of minutes. Okay? So from 1 to 51, excluding 51. So basically, 1 to 50 lang to. Okay? So that will be our concept. No? Now, when you try to run this one, okay, now we have a time, okay, it's arranged from 1 to 50. Now we need to create a trend, no? So our trend will be the time multiplied by 2.75. Okay, so let's pretend that we have a sensor, okay, measuring demand for electricity. But we try to ignore units muna for simplicity purposes. Okay, let's try to run this. Okay, now that we have the time series components and the trend, okay, so what follows next is to show you the trend as a function of time. So basically, ano yung magiging output nito? Ito, nakikita nyo rito, the trend versus the time. No? So our time will be from 0 to 50, okay, in terms of electricity demand. Okay, so you will notice that while we have, there is an increasing direction, no, in terms of the trend. No? So naka-uptrend tayo from 0 to 50. So from the values of 0 to 140, we are reaching actually the maximum demand for electricity at the 50th minute. Okay, so let's try to run this. So you can see that is the trend. And now let's try to generate a seasonal component. How do we do that? No? So we do that by adding 10. And then, of course, we need to use sine of the time multiplied by 10. So this is a NumPy. So basically, yan yung iraran natin. And then we plot the seasonality. Okay? So this is the seasonality versus the time. As you can see from here. So basically, yung nakita nyong image from above, ito rin yung pinapakita rito na image. All right? Now, to construct the residual component, so what do we do is to, of course, we try to if you want to have the same output like mine, you have to use the same random value. No? So, ang ginamit ko is random value 10. For the residual, I use the random normal location 00, scale 1, size is depending on the length of the time. Okay, so let's try to run this. And this is the plot of the residual. So nakita natin yung plot ng residual ng electricity demands in terms of residuals versus the time. Okay, you can see here the difference between the three, no? So this is the upward trend using the trend, and this is the seasonality, basically from our example, generated fictional time series, and then we have the residuals now, which is equal to this image that you can see. So just a quick recap, we created data for fictional demand of electricity as measured by a fictional sensor. And we did this by creating the three necessary components of the series data, which is the trend, seasonality, and residuals. Our next step is to aggregate the three components. Now, when we say aggregate, we try to add these components all together to create the time series data. And we'll do this for two different types of models. No? We have two different types of modeling for time series. We have the additive modeling and the multiplicative. Now, how do we do aggregation? So the formula for additive is the additive time series, which is equal to OT. Okay, that is the output or the generated time series, which is equal to the sum of the trend, no? In terms of time. Okay, the trend in terms of time, the seasonality in terms of time, and the residual in terms of time. So pag pinag-add natin yung tatlong yan, we will have an output of the additive time series. So the T here that you can see is a variable representing a particular point in time. So basically, ito yung formula na yan. No? So the additive can be equal to the trend, seasonal, and residual. No? To interpret that, using, of course, we need to run this one first, no, before we plot it. Okay, you can see now that the electricity demand in terms of the modeling of the additive time series, when we try to combine those trend, seasonality, and residual, we will have a signal of a time series, something like this. Okay, so we can now clearly see the trend and seasonality as expected. No, so still we can see an upward trend. Okay, in terms of the signal, no, that was generated by our fictional electricity demand. For multiplicative, so basically it's different from the additive. No, the output is generated by multiplying the components of the time series. No, multiplying the time or the trend, sorry, in terms of time, multiplied to the seasonality in terms of time, and multiplied to the residual in terms of time. So ignoring residual to make pattern more apparent, no? So we created a value that that ignores the residual, no? So we do that by multiplying the trend seasonal. So our multiplicative will be equal to the product of the trend, seasonal, and the ignored residual. So basically, yan yung ating product. And the plot of that is equal to this image that you can see from here. Okay? So this is the multiplicative time series, somehow similar to a seasonality. However, ang makikita nyong difference is that iba ang trend, no? The trend is still upward, no? And it's still going on and on and on. And when this time goes on and on, it will continue to rise, no? In the level of the demand of the electricity. Okay? Now, how do we do time series decomposition? So this is the third part, no? So we'll try to reverse direction. We'll try to decompose this model, no? Like we can decompose a multiplicative model, and we can also decompose an additive model. Okay, but how do we do that? So now that we have an additive and multiplicative data, we can try to decompose them into three components. So please note that the goal here is not to understand how the decomposition works. No, rather the goal is simply to see the time series data we previously constructed can be decomposed into its three constituent parts, no, which are trend, seasonality, and residual. No, you can check this link. Okay, I think hindi ko pa na-upload tong module 4 notes na ito. Siguro later I'm going to upload it. Just remind me later to upload it. No? the link here that you will see is the details on how the following method works. So let's take a look, no, uh, by looking at the additive decomposition. So we need some libraries from stat models. So we try to look on TSA seasonal, and we'll try to import seasonal decompose because we're doing some additive decomposition. So what we do here is to create a seasonal decompose using the following parameters, such as X will be the additive, the model, of course, they have the additive, and the frequency is equal to 6. So you can try to study the different parameters by using Shift Tab, okay, so that you will understand it better. So when you and then we try to decompose the following components, such as the estimated trend. You can see here that we did not write trend, seasonal, and residual. No, we write here estimated trend. No, so ayan, using this SS decomposition, which is this function, no, that this seasonal decomposition, we can now get some values of the trend, the seasonal, and the residual. Okay, so let's try to do that by running it. Now that we run it, okay, let's try to plot each component. No, so these are all the figures. So you can see here. So we will plot the original, the additive, and then we will plot the trend, the seasonality, and the residual. So these are the result of that. No, so we have the original signal, and then we have the trend looking like this, and then we have the seasonality, estimated lang to, no, and then we have the residual. So the blue line in each plot represents the decomposition, and there is a legend in the upper left corner of each plot to let you know what each plot represents. So this is a residual, seasonality, trend, and original. Okay, and you can also see the decomposition is not perfect with regards to seasonality and residuals, but it's actually pretty close. So note here that you may notice both trend and residuals are missing data towards the beginning and the end. No? So nakikita nyo hindi siya nawala yung values dito, no, sa part na to. Sa part ng 0 at saka sa part ng malapit na sa 50. Bakit kaya? So it's the same with this one, no? With the trend, no? So basically, bakit daw? Because this has to do with how trend is calculated, no? Which is beyond the scope of this particular lesson. Okay? And the residuals are missing simply because the residual is equal to the output minus the trend and the seasonality. So missing trend values means missing residual values as well. No? So in other words, there is nothing wrong with these graphs. For multiplicative decomposition, so we'll just use the function and the model. So instead of additive, we replace it with multiplicative. Instead of using the model for additive, we use the multiplicative. Still, we're using the frequency is equal to 6. No? So basically, ganun pa rin yung idea. We tend to create some estimated trend, seasonal trend, and residual using the function SS decomposition. Okay? And then we'll run it. And then there is the result of the plot. No? So this is the original signal. You can see now the trend, which is something has been missing here for the trend, no, for the 0 values and the 50th values, and then as well as the residuals, no, may mga missing siya. So again, the decomposition does a relatively good job picking up the overall trend and seasonality, and we can see the shapes follow the patterns that we expect, no. So nakita naman natin, okay naman yung trend ng seasonality. So ito rin yung trend ng trend, okay? At nakita rin natin yung trend ng residual, which is similar to the residual signals, no? Now, let's try to understand about stationarity. So what is stationarity? So the observations in a stationary time series are not dependent on time. Okay? Time series are stationary, no? If they do not have trend or seasonal effects. So paano natin masasabi na merong stationarity? Kapag ka walang trend, okay, remember this if they do not have trend or seasonal effects. So the time series can be considered as stationary time series. Okay? So that means that it is a stationary time series when it does not depend on time. And summary statistics calculated on time series are consistent over time, no? Like the mean or the variance of the observations. So there are two things that you can see here. Okay. So the assumption one is what we call the constant mean. So when we say constant mean, we have a constant average, no, of the signals, no. As drawn here, the colored red here is in the constant mean. No? Yung second one is the assumption that we have a constant variance. No? The variance is in the upper values and the lower values of the time signals. No? Yan. Okay? No. So again, what is stationarity? Again, it's called stationary if they don't have trend or seasonal effects. Okay? And in order for time series data to be stationary, it should exhibit four properties over time. Number one, it should have a constant mean. It should have a constant variance. There should be a constant autocorrelation structure. And number four, there is no periodic component. So you'll see here that the mean, variance, and periodic component, also known as the seasonality, should be familiar to you. No? Of course, autocorrelation may not be. So what is autocorrelation? It simply means that the current time series measurement is correlated with the past measurement. Now, for example, today's stock price is often highly correlated with yesterday's price, no? Something like that. And to discuss these things simply, we must introduce the idea of lag. No? Ano ba ibig sabihin ng lag in terms of time series? Lag is a fancy term for delay. Okay? So pagka sinabi nating lag, may delay. Say you wanted to know if today's stock price correlated better with yesterday's price or the price from 2 days ago. So you can test this by computing the correlation between the original time series and the same series delayed one time interval. Okay, so therefore, the second value of the original time series would be compared with the first of the delayed. So you can imagine that there is an original time series, tapos nag-delay tayo for example ng 1 second on each time point. Okay, so yung second value na yon will be compared to the original time series, no? And the third original value would be compared with the second of the delayed, and so on, no? And if you perform this process for a log of 1 and a log of 2, it would yield two correlation outputs. So this output would tell you which log is more correlated. Yun yung tinatawag na autocorrelation in a nutshell. So autocorrelation again is a key concept in time series analysis. So what is autocorrelation? It's the correlation between the measurement of at two different times. So it can be a log 1 or a log 2, something like that, no? And the time interval between values is called the log, no? And for example, yan, sabi nga dito, stock prices may be correlated from one day to the next with a log value of 1, no? And often results in a pattern whereas a time series without autocorrelation will exhibit randomness. So you'll see here that this is a stationary time series. Okay? This is a stationary without correlation. But here, with correlation, it has a log structure. So makikita nyo rito yung non-stationary data, okay, with log structure. Yan yung itsura ng non-stationary data with log structure. This one has no autocorrelation. That means ito wala tong log structure. Okay? There is also an assumption tree. No? We have assumption 1 and assumption 2. So ano ba yung assumption 1 natin kanina? Constant mean, constant variance. Yung pangatlo is the constant autocorrelation structure. No? A structure or a stationary time series has a constant autocorrelation structure throughout the entire series. No? If the autocorrelation remains constant through the series, a simple transformation can be used to remove the autocorrelation. Now, bakit importante ang stationarity? Okay? So this is fundamental in many time series forecasting models. No? And without it, many basic time series models would break down. So transformation can be applied to convert a non-stationary time series to a stationary one before modeling. So while there are more advanced time series models that can handle non-stationary, that is beyond the scope of this lesson. So this is an example of a non-stationary data with trend. No? So you can see the trend, it's an uptrend. No? This is a sample of a non-stationary data with heteroscedasticity. Medyo mahirap banggitin, no? Heteroscedasticity. Yan. So you can see a constant variance here in terms of the signal that was generated. Okay? This one naman is what we called a non-stationary data with log structure, no? As similar as this one. Okay? This is a time series that has autocorrelation, similar to this one. No? Another one is a non-stationary data with seasonality. And yun yung mga itsura. No? Para makita natin yung differences ng non-stationary data with stationary data. This one naman is a non-stationary data with trend plus seasonality. I'll try to have some example of this later. Kung paano na-generate itong mga ganitong klase ng data. And so let's start to apply what we've learned. Okay? And we'll begin by creating a variable called time. So magkikreate tayo ng variable called time. And then we'll define it equally spaced time intervals. No? And then we'll sample values from a normal distribution with mean of 0 and a standard deviation of 1. Essentially, we're creating a noise, actually, no? Which is a stationary time series. In other words, the series of data exhibits all four properties required of a stationary time series. So let's try to do that by creating a random value of 42. So we have a time, and we have a time of values of 100, no? And then we randomly draw some samples, no? From a normal Gaussian distribution. So basically, when we try to run this one, so it will print just the, of course, it will print just the multi-line comment. No, this is the document string of the Python code. So it makes sense to generate a run sequence plot to visually confirm stationarity. No? So we'll try to create a run sequence plot function para hindi na tayo gagawa ng pagpa-plot. No? So function na lang yung i-call natin, and basically itong mga values na to ng plot, yun ang ibibigay sa atin later. Okay? So this is just to run the sequence of the plot. So basically, ano yung parameters niya? We have the X and Y. We have the title, the label, and the X label and the Y label. Okay? So let's try to run this function. And then let's try to run this function, no? Using time and the stationary data. Okay? So saan galing yan? This is the time that we generate, and then the stationary data. Okay? So ito yung magiging output niya. So this is now what we call a stationary time series. Okay? Okay, now notice in the plot that there's no clear trend or seasonality. And this time series data appears to be to meet the four conditions of stationarity. Now, what is that? Those are constant mean, constant variance, constant autocorrelation, and no periodic component. So let's look at one more example. And this is a concrete example of data with a log of 1 that has constant autocorrelation. The first thing that we need to do is to seed to start the series. No? So we have 3.14 as our seed. And then we create a log. Okay. And then we try to to create the log values and the seed values, no, at this particular time. So we try to run this. Of course, we need to run this one first. Okay, and then we run. Okay, we na-run na natin to. So we try to run now the sequence plot, and we use the title non-stationary data with log structure. So ito na ngayon yung itsura nung time na kinreate natin. Okay, nakapag-create na tayo ng time earlier, di ba? Time natin is it's an array of 100 basically. Okay, so and then from here you will see some explanation also, no, that this code empty like it returns a new array with the same shape and type as a given array. Okay, so when we try to run this one, so it will give you a sequence plot similar to this, which is an example of a non-stationary data with log structure. So you will notice now that the current value is highly correlated with the past value. And at this point, you may wonder how to check if a time series in fact meets the 4 conditions of stationarity. So we will learn in section 2 how to check that, no? So section 1 pa lang ginagawa natin. However, starting your analysis with the run sequence plot is an effective way to get a handle on whether your data has the appearance of being stationary. To drive that point home, let's discuss some ways to generate non-stationary time series. No? So when we have a trend, that means nagbabago yung mean. Pagka meron tayong heteroscedasticity, nagbabago yung variance. At kapag meron tayong seasonality, meron tayong periodic component. Okay? And then of course, we can add the trend and seasonality for a particular time series. So we will plot the results of each so we can compare non-stationary to stationary data. So how do we do that? So we create first a trend. Okay, so basically yun yung time natin na kinrate kanina multiplied by 2.75. Tapos dagdagan natin siya ng stationary. So ano ba yung stationary natin dito? Yung value ng stationary natin. So ito yung value ng which is the random samples that are distributed using normal Gaussian distribution. So ayan yun, no? So let's go back. So let's run this. And then we try to plot the non-stationary data with trend. Yan, okay. So ganyan yung itsura ng ating image o ng graph natin. So non-stationary data with trend. So the question is, why is this data not stationary? Because the answer is this, the mean changes over time. Okay, so when the mean changes over time, it's called a non-stationary time series. So how do you say it's a heteroscedasticity? So we can do that by, again, meron tayong random sample dito na, random value sample na 1, 2, 3, 4. And then we create a random data of level 1 and level 2. And then our heteroscedasticity is the, we'll try to append both of the data that we created. Then we run the sequence plot. Now we can see here that that this part is the level 1 and the other part is the level 2. So you can see now that we have a non-stationary data with heteroscedasticity. So bakit siya tinawag na non-stationary data? Okay, because the variance changes over time. So yung variance dito ay iba sa variance dito. So makikita nyo yan dito sa image dito sa taas. Yung talking about the variance, this one, no? So yung variance dito, it changes over time. So iba yung variance dito from the level 1. So pagdating sa level 2 signals, iba na rin yung variance niya. So when the variance are changing over time, so non-stationary yung data natin. Alright? So, paano naman natin masasabing ang signal ay may seasonality? So, we can create a seasonality. So, ito basically, ginawa na natin to kanina so that we can create a non-stationary data with seasonality. So how do we know that this data is not stationary? If there is a periodic component. So nakikita nyo, each period, meron siyang component. Okay? So nagbabago siya. So it's not stationary. So it changes over time. So basically, yun ang ibig sabihin nun, no? Now, let's have a trend and seasonality. Again, this is not a stationary data again, no? Why? Because the mean changes over time, no? And there is a periodic component. May periodic component siya, and at the same time, meron siyang nagbabago yung kanyang mean over the time. Okay? So pag nakita natin yung signal ganyan, nagbabago, that is not a stationary data or time series. Okay, how do we identify stationarity? So in this part, we will identify common techniques which is used to identify if a time series is stationary or not. Sorry. Specifically, we will cover run sequence plots, summary statistics, and histogram plots, and then we'll try to understand augmented Dickey-Fuller test. No, so this is used to check. No, this augmented Dickey-Fuller test na to ay ginagamit siya to test whether the signal is stationary or not. No, so in statistics, this augmented Dickey-Fuller test test the null hypothesis that a unit root is present in a time series sample. So the alternative hypothesis is different depending on which version of the test is used, no? But it's usually stationarity or trend stationarity. Okay? So yun yung basic information about augmented Dickey-Fuller test. So running the sequence plus, no? So we have the nirun na natin siya, no? We can see here that the run sequence plot should be old hat by now. Alam na natin kung paano to ginawa. Okay? So using the time and the trend seasonality. So we try to run this and we have the following figure, no? Okay, wait, hindi siya naka-define, no? Hindi daw naka-define yung ano. So we need to define this. Oh my goodness, ano nangyari? So meron ba tayong mga hindi na run? Yan, okay. Let's try to run this. Yan. Parang meron hindi tayo na run, no? Yun, okay na. So ayan. Eh, pagdating dito, ayan, okay. So nag-run na siya, no? So this is an example of a trend seasonality. Yung parang ito yung itsura niya, di ba? Trend plus seasonality. Okay? So let's try to use the summary statistics and the plots, no? So we'll try to split data into 10 chunks. So you can see here that the ginamit nating data is yung trend. In-split natin siya into multiple sub-arrays. Ginamit nating split I10, no? Yan. So we'll try to run this. So ayan na, split na siya. So that is the multi-line comment. And we'll try to determine the summary statistics, no? So we'll try to print the chunk. Okay? Siyempre, maglo-loop tayo dito. So gagamitin natin yung for loop from 1 to 10, no? Maglo-loop tayo from 1 to 10 kasi 10 lang yung sections natin. And then ilulup natin yung kung ano yung mean sa bawat looping natin, no? So ano yung mean at saka ano yung variance. So ito yung output niya. So nakita nyo, doon sa chunk 1 meron tayong 12.82. Ang variance niya is 62. Tapos yung mean niya naman by this time sa number 2, 39. Naging 60 naman yung variance. So ano mapapansin niyo? Pabago-bago yung mean, pabago-bago yung variance. Therefore, ano mapapansin natin? Is this stationary or non-stationary? Any answer? Okay, I think ako lang ang nakikinig sa sarili ko. Okay, and never mind. Okay, I'll just continue. Okay, so siguro yung iba hindi mo na nakikinig, may recording naman, doon na lang ako mag-aaral kung kailangan. Okay, anyway, you can see that if the mean are changing and the variance are changing, so therefore this is a non-stationary data. So nagbabago yung mean, nagbabago yung variance. Stationary data to. Okay? So let's try to use the tangent method, no? So this is a shortcut method in NumPy to get the same results without having to run through a for loop, no? So we have a mean. So we can use the mean using the chunks data. We have the chunk data of 1 to 10, di ba? And then the axis is equal to 1. And then the array that will be produced is the following, no? So you can see from here. So ito yung values na nakuha niya, 12.82. The same lang yan dito sa values na to. So yung last part is 259. So this is the tangent method, no? It's the same with this one. For the variance, so pwede natin gamitin yung function of variance to get the chunks and the axis, which is equal to 1. So yung values na nakikita nyo rito, 62.548 hanggang 61.64, yun din yung values na na-acquire natin dito. Okay? So you will notice how the values in each array perfectly matches the values in the for loop above, no? Ang explanation natin dyan, while the variance is relatively constant over time, the mean is clearly changing, which means this data is not stationary. Okay? So note, we do expect some fluctuation in values, and it's highly unlikely that either the mean or variance will be exactly the same from chunk to chunk, but it should be close. Now, if you wanted to get even more sophisticated, you could run a statistical test to determine if the difference in means or the difference in variances is statistically significant. However, that is beyond the scope of this tutorial. Okay? Another useful tool is to plot the means and the variance. No, we can do that by plotting it in a histogram. No, so we can plot the trend in the form of a histogram. So let's try to do that. So ito yung result natin. Okay. So if you plot a histogram of the time series, so ito yung structure na makikita natin. No? So you can see a normal distribution, which gives us a confidence that the mean and the variance are constant. No? It's certainly not definitive, but gives you a good indication. Okay? And also here, you can see what appears to be a uniform distribution. No? You could expect for time series with trend, and this data is not stationary, and the histogram plot provides insight into that fact. No? And let's try the same thing on the stationary data. So stationary data naman gamit natin. Run natin siya. So this definitely looks more appropriately normal. Okay, again, out of scope to. So if you want to learn more about the normal test, this is from Python's library. So if you want to check whether this sample differs from a normal distribution, you can click this link, okay, to determine. No? So finally, the augmented Dicker-Fuller test. No? Saan ginagamit again yan? So it is used to actually use for unit root test for stationarity. No? So this can be used with actually serial correlation. No? So ADF ang abbreviation nitong augmented Dickey-Fuller test, and it can handle more complex models because this one is augmented. No? Sabi nga natin, no? It's different from the other formula. And this is used to actually test the null hypothesis, no? That a unit root is present in a time series. So basically, ang mini-measure dito is the stationarity. Okay? So this is a procedure to suss out whether a time series is, suss means to find out, no? Is a stationarity or not, no? Or stationary means it doesn't do anything, no? And we won't go into all the nitty-gritty details, but here's what you need to know. When we say null hypothesis, that means the series is non-stationary. When you say alternative hypothesis, that means the series is stationary. And like any other statistical test, you should set a significance level or threshold that determines whether you should accept or reject the null. No? The value of 0.05 is common, no, but depends upon numerous factors. So let's try to see how to run this test in Python. No? So gagamit tayo ng augmented Dickey-Fuller test. So add Fuller, import natin yan sa stat models. So you can see some add Fuller, ang gagamitin natin data ay stationary. So meron tayong mga values dito, ADF. So isa-isahin natin to, pero i-run muna natin siya. Now that we run it, we'll try to briefly discuss about the important outputs, no, from this ADF test. For example, if you want to print the ADF, no, so ADF is the value of the test statistic. So that's the augmented Dickey-Fuller test value. Okay, the more negative the value, the more confident we can be that the series is stationary. So you can see here, this is a -10, therefore we can say that the series is stationary. Okay, that may not mean anything to you just yet, but the p-value should, no? Ano naman yung p-value? So the p-value that you see here, okay, is the same as this one, no? So when we try to print the p-value, it's around 1.16, 555, and so on, raised to -17. So definitely that is 10 raised to -17, no? So it's interpreted like any p-value. So once we set a threshold, we can compare this p-value to the threshold. Either we reject or fail to reject the null. Now here, the p-value is very close to 10 raised to -17. So what do we do is to reject the null that this is a non-stationary. Okay? When we try to print the nubs, so ano naman yung nubs? The variable nubs is simply the number of observations in the time series. No? In this case, meron tayong 99 nubs or number of observation. Kaya sa tinawag na nubs. Yun namang critical values that you see here, these are variable which provides test statistic thresholds for common significant levels. No? Here we see a test statistic of roughly -2.89. So you can see here, ilan ng 1%, -3, ilan ng 5%, -2, at ilan ng 10%, -2.58. So you can see now that the test statistic of roughly -2.89 and lower is sufficient to reject the null using a significance level of 5%. Okay? So you may have noticed two outputs we didn't discuss. No? So how do you define the IC best and the I think the use log and the IC best, no, hindi natin na discuss yan because that is outside the topic, no. So you have to click this link if you want to know more about use log and the IC best. All right, now let's try to add and combine the trend data and the using sir, pwede possible po ba magkaroon ng zero value for ADF? What if zero po ang value ng ADF? Is it stationary or non-stationary? So magandang question to, no? So ang ADF value is equal to 0. So how do you determine that, no? Actually, when we do an applied test on a certain model, no, for example, no, so I'm looking for answers in the internet actually, so I'm being honest, ayoko namang manghula. So that is a very good question kasi, no, so pwede kasing maging 0 yung value, but actually when we're doing some statistical values and information, mahirap makakuha ng eksaktong 0. It's either it's almost 0 or a negative value of 0 na. Almost 0, no? Almost 0 na talaga siya. Okay, but definitely according to some some references here that I found. It's very hard to find an answer that the ADF value, like in this case, no, to tong trend and ADF na to, you will see that the value is almost close to zero, but it's not zero, diba? So definitely mahirap tayong makakita ng ADF value na zero talaga siya. Okay? Kasi it's either we reject the null or we accept the alternative. So parang ganun yung case nun, no? So you can see here that the values of, gumamit tayo ng add fuller. Okay, ginamit natin gumamit tayo ng trend values at gumamit tayo ng regression which is equal to Z. So tiningnan natin kung ano yung value ng ano. So para saan ba to, sir? Saan ginagamit tong add fuller na to? Pang test lang to, no? Actually hindi to pang ano. So ginagamit lang natin siya pang test to determine if the data set that we have is stationary or not. Okay? Yan. Pag ni-reject yung null sa non-stationary yung data, ibig sabihin po ba nun stationary yung data, di ba? O baligtad? Di ba, sabi kanina, according to the information that we have, ayan, no? Sabi dito, kailangan i-compare natin yung values na nakuha natin, no? So, kapag ka yung p-value na nakuha natin, no, ay very close na siya to zero, so what we do is to reject the null. And that means if we reject the null, this data is non-stationary. So tandaan nyo yun, i-note nyo yun. Now, when we reject the null, we accept the alternative. Di ba? So yun lang naman yun eh. When we reject the alternative, we accept the null. Okay? Baligtad lang naman yun eh. Okay? So when we reject the null, that means the data is non-stationary. And that happens when the value is very close to zero na. So sabi nga ni kanina dito, kapag ka very close to zero na, we're not talking about the ADF, no? So sa ADF kasi, mostly, ang magiging answer doon ay negative, no? Pagka negative na siya, okay, ang susunod nating titingnan daw ay yung p-value. Ngayon, sa question pa rin ni Dalmasio, kapag ka zero yung value ng ADF, no? So, does that happen? So, katulad nito, hindi to masasabing zero to kasi may value pa, malaki to, no? In statistics, 0.33 is very large amount. As you can see, the p-value, no? If this is the ADF, the p-value is 0.97, which is almost equal to 1. Diba? Okay? So therefore, ano ngayon ang ating makukuhang dito, no? So let's try to continue. So as expected, we fail to reject the null. Okay? But the trend data is in fact non-stationary. So we'll try to test on the log data, yung log data naman, no? Gamitin natin kanina trend, ngayon naman log data. So anong value makukuha natin sa ADF? Ano rin yung value makukuha natin sa p-value? So niran natin yan. So makikita nyo, negative 2.64 yung ADF niya at 0.08 yung kanyang p-value. So you may find this surprising result as ADF says the series is non-stationary. Even though the series does have a constant autocorrelation. It's not yet in a form that is technically stationary. Therefore, we'll learn in the next section how to apply what we call the transformation so that we can accomplish that. No? But before that, no, there's a good news. You now have several tools in your toolkit to help you figure out if a given time series is stationary or not. So using the ADF, no? That's one of the tools that we can use. But for the meantime, let's pause for a while. So mag-ano muna tayo, mag-break muna tayo ng 10 minutes. So I'll try to